Okay, we're going to work on lesson 1.4 today. We've already talked about slope-intercept form. Today we're going to talk about point-slope form and standard form. We're also going to touch on parallel and perpendicular lines. So those are the two forms we're going to use, and then we're going to worry about parallel and perpendicular as well. Point-slope form is a very useful form because if you don't always know the y-intercept, and the y-intercept isn't always a nice point. So if you know any point on the line, x coordinate and y coordinate, and you know the slope, then you simply slope goes there, y coordinate goes here, x coordinate goes here. So if I had y minus 3 equals 2/3 times x minus 7, I would know that I have a slope of 2/3 and I have a point of 3/7. You got to watch out. Whoa, I got that backwards. It should be 7/3. Almost made my first mistake of the year because the x coordinate is over here. So that's a common mistake, and the y coordinate is over here. Also notice the subtraction is part of the problem. Okay, so you got to watch out for that. So if we're going to read this one, I'm going to have a slope of 2, an x coordinate of +4, and a y coordinate of -7. So if I was going to graph this, I would go to 4, -7, and apply a slope of +2. I put it in fraction form, rise of 2, run of 1, rise of 2, run of 1, rise of 2, run of 1, and so on and so forth. And I could go the other direction, and you can really see now why this could be very useful, because we don't always have a nice y-intercept. Down here, I have a slope. Let me change colors there for you so we don't get mixed up. Let's go dark blue, sure. A slope of 4, and then I have a point of +1, +3. Watch out for those x's and y's. 1, 1, 2, 3. And then I apply a slope of 4, 4 over 1. Rise over run. Up 4, right 1. Down 4, left 1. Ooh, there's a nice y-intercept of 1. And then we connect the dots, and I got close enough. Okay, so this is where we really get the ticket. Write an equation. I got an x and a y and an m. So I do y minus y1 equals m times x minus x1. And that's technically done. I would change the y minus a negative to that. And if they asked you for it in point slope form, you're done right here. But this is where we can actually we can go a little better. I like to call it, we got 2 steps. I'm going to distribute this. The Texas 2-step here. -3/5 x plus 3. And then second, move that guy over. And look at how fast we are in y equals mx plus b. So I get the answer in point slope form, and I can get the answer very quickly in slope intercept. Same thing here, x, y, m, y minus y1. See what I did there? Minus a negative equals m times x minus x1. Minus a negative, I went ahead and did that right away. In point slope form, we're done, but they asked for it in slope intercept, and that'll happen a lot. Y plus 1 equals 2/3 x plus 2. I distributed my slope, and I quickly subtract 1, 2/3 x plus 1. And now we've got it in slope-intercept form. We are good. Write an equation. Oh, I don't have a slope. Well, what do? Well, the first thing you're going to need to do is do y2 minus y1 over x2 minus x1, which is 10 over -5, which is -2. So I have a slope of -2, and I can pick either point. I'm going to pick the first one, not sure why. Y minus 3, -3 is y plus 3 equals m times x minus 2. So if I wanted to graph that, I could just go to the 2, -3, and apply the slope of -2. down 2, right 1, up 2, left 1, up 2, left 1. And we have it. Also, I can clearly see what my y-intercept is, and if I wanted to change that around, I could go real quick. Negative 2x plus 4, slide that 3 over, and I will end up with plus 1. It doesn't matter which one of these I use, I'll get the same answer. So the negative 3, 7 would actually be up here. Wouldn't be a great way to graph it since it's off my graph, but it still works itself out, and it would work itself out to y equals negative 2x plus 1. Standard form is when we have x term first, y term second, constant on the right of the equal sign. Okay, a and b are not both 0. That's important. A's got to be positive. Positive. Okay. B can be anything, but they're integers. They're all 3 integers. Integers. That is whole numbers, not fractions or decimals. And their greatest common factor is 1. I like to think of that as reduced. So we have, you can't have 2x minus 4y equals 6. They're all divisible by 2, which could be simplified to that guy. That's standard form. A is 1. It's a positive integer. B is negative 2. A is positive 1. I just kind of put a dot there. B is negative 2. That's fine. It's an integer. C is 3. Put these in standard form. The first thing I would do is I would move the x coordinate over. So I subtract that over. So I have negative 2/3 x plus y is negative 4. Well, I'm not allowed to have fractions, so I should multiply everything times 3, and I get negative 2x plus 3y equals negative 12. So I have them all as integers now, but I'm also not allowed to have a to be negative. So divide everything by negative 1 or multiply everything by negative 1. And you're basically changing all the signs, right? I get positive 2x minus 3y equals positive 12. And now I'm good. A 2 and a 3 and a 12 is reduced. It seems like they should go further, but we can't. Next, I'd maybe move this one over here. And that's the great thing about equality. So if I do that, 16 over 2 plus 5/3 y. Excuse me, that should be a minus. I gotta grab my eraser. Just one sec. There we go. It's almost like I never made a mistake. I didn't. Okay, so we've got, what do we got now? Let's use purple, sure. So I subtracted the 5/3 y. So I need to clear out both a 2 and a 3. Can I multiply this whole thing times 6? 16 times, negative 16 times 6, I believe that's negative 96er. And then a 6 here, 6 divided by 2, that's going to be 3x. And a 6 here, that's going to be minus 10. Now, I would rewrite this. Equality means we can just write 3x minus 10 equals negative 96. Oh, 10y, excuse me. 3x minus 10y. And there you have it. Standard form. Positive integer, integer, integer. Greatest common factor is 1. They can't be divided by a number greater than 1. Parallel and perpendicular. Here's the thing about parallel lines. Parallel lines, two non-vertical lines, are parallel if and only if they have the same slope. Same slope. Obviously different y-intercept, otherwise they'd be the same line. Okay, so you're looking for parallel, same slope. Okay, perpendicular. Slopes are opposite. That means positive or negative. One has to be positive, one has to be negative. Reciprocals. Flip it over. And that also means that the product multiplying them together will always get you negative 1. So you can always check by multiplying their slopes together. If you get negative 1, they are perpendicular. They form a 90-degree angle. Opposite means plus or minus. Reciprocal means flip it over. So here we go. Write an equation in slope-intercept form for the line that passes through this. So that's my x and y, and is parallel to this. Parallel. My slope is negative 5. My parallel slope. And this is the symbol for parallel. Parallel, it looks like a tall number 11. Parallel slope is negative 5. And then I have a point of 3, negative 2. And I can go with y minus y1 equals m times x minus x1. Watch that negative, minus -2. Oh, I got those backwards. I did it again. X, Y. Unbelievable. Almost made my first mistake of the year. So this should be +2. I got to get an eraser. I got to fix this. This is no good. Okay, so let's talk about where these guys go. And you can see that's probably one of the spots you got to be careful of. Y minus -2 equals m times x minus 3. All right, so that's point slope form. We want slope intercept. Texas two-step says distribute the -5 and subtract 2. Y equals -5x plus 13. Notice, I would much rather do 1, 2, 3. 1, 2. Apply the slope of -5. Down 5. Right 1. Up 5. Left 1. And we have a line. And that's parallel to, if I graphed that, I would go here and go up 5, right 1, and, whoa, that's a terrible drawing. You get the picture, though. They are parallel. Parallel lines never intersect. Okay, now we want perpendicular. So I've got the slope of this line is 3. Here's my symbol for perpendicular, upside down T. The perpendicular slope is opposite reciprocal, and I've got an x and a y. Y minus y1 equals m times x minus x1. Okay, now I can graph these two. Let's see if they're going to be perpendicular. Down 2, and then a slope of 3. Up 3, right 1, up 3, right 1. Good, good, good. I'm doing the best I can with the line there, and I can graph this one at 3, 5. 3, 5 is going to be up here, and it's got a slope of -1/3. Down 1, right 3, up 1, left 3. Oh, look at that. Look at that. Even my bad drawing makes it look like we have a right angle, don't we? Yes, we do. Again, if they wanted this in slope intercept, I should distribute y minus 5 equals -1/3 x plus 1. Add 5, and look at this. Look at me now, look at me now. I'm doing great because the y-intercept is 6. There it is, whoop. There it is, whoop. And we're done. So do your homework and have a great day.